Hello, everybody, and welcome to another Grassroots Health webinar. It's one of our Sunshine Month study hours, and I am very honored to have Dr. Cedric Garland here with us today, who has been with Grassroots Health since its founding. For those of you who are not aware, Dr. Garland is the principal investigator of our vitamin D action study. And he worked very closely with Carol Baggerly, our founder, to really create the dream of grassroots health and set it on its right path. And so, Dr. Garland, welcome today. I'm going to go ahead and introduce you, and then he's got a really great presentation today to share with all of us. So, yeah. All right. And so today, Dr. Garland will be reviewing the research that shows whether or not sunshine exposure might actually be related to a reduced risk of cancer. And I'm talking many, many different types of cancers. And he'll be going through what the studies have been showing for pretty much decades now. And I did share just a few publications with everybody before the webinar, one of which was one of Dr. Garland's publications titled Vitamin D Supplement Doses and Serum 25 Hydroxy Vitamin D in the Range Associated with Cancer Prevention. And then another, Do Sunlight and Vitamin D Reduce the Likelihood of Colon Cancer? So, a little bit more about Dr. Garland. He is the Professor Emeritus from the Department of Family Medicine and Public Health at the University of California, San Diego, which is where I went to school. As I mentioned, he's also the principal investigator of our vitamin D action study. He is an internationally recognized epidemiologist who helped pioneer the early research linking vitamin D, sunlight exposure, and a reduced risk of cancers, especially colorectal and breast cancer. He has published over 150 articles and books on that subject, often in collaboration with his late brother, Dr. Frank Garland, and other researchers like Dr. Edward Gorham. He is the co-author and landmark peer-reviewed studies supporting the role of vitamin D in cancer prevention, a longstanding contributor to nutritional epidemiology and preventative medicine with decades of published work that has really truly shaped the global vitamin D research and policy field. I have spoken to so many other researchers, doctors, practitioners who really revere Dr. Garland and his research as one of the true pioneers linking sunlight to and vitamin D to a reduced risk of cancer. And one of my favorite little facts about Dr. Garland is he was awarded a knighthood by Italy in 2016 for his research on vitamin D and cancer prevention. So I just think that's so cool, Dr. Garland. So just a few notes before we start. As always, we will record this and we will share this on our website and on our YouTube channel. Please enter your questions into the Q&A box and we will address those at the end of the webinar. As I mentioned earlier, anybody is welcome to join the D-Action study, and doing so, you can use a home vitamin D test kit to measure your vitamin D level, receive education and tools about how to really optimize that level for your health. Go to grassrootshealth.net. And one piece of exciting news I'm sharing today is that our Moving Vitamin D Research into Practice e-course has just been updated and approved for 11 nursing credits. So 11 hours of nursing continuing education units. We're having a launch special right now for 30% off. Anybody can take the course. It's a really great in-depth course on vitamin D research, on how to implement certain protocols into practice for yourself, for patients, for anybody around you, and how to really move the vitamin D research into practice among all levels and spheres of influence. And I really encourage anybody to check that out. So with that, I will gladly hand it over to you, Dr. Garland. Give me a second to switch slides here.
And hello to participants throughout the world, from Washington, D.C. to the People's Republic of China. Glad you're tuned in. And it's a pleasure to be with you today. While Jen is setting up, I'll tell you that one of my heroes is William Thompson, whom every sixth grader knows as Lord Kelvin, and who would give you an argument if you said that nothing was absolute, since his specialty was the discovery of absolute zero. And he led the way to the first law of thermodynamics, a Greek term referring to heat and work that revolutionized engineering. And I also have a hero in Sir Isaac Newton, who in the 1600s, at age 21, discovered Newton's first law of motion, saying that things that are at rest remain at rest and those in motion remain in motion. But we haven't so far had laws of nature that govern cancer. And I plan to introduce today to you uh, evidence supporting some new laws that could be enacted immediately by society, almost as engineering an end to cancer, based on epidemiology, which is usually where ways of preventing disease come from tuberculosis to cholera to the Black Death. And so I'd like you to buckle up. It'll be, you want to buckle up because there's going to be a lot of information. Now, as you know, if you sometimes watch television like CNN, you'll notice that editing has gotten so you see a slide for a fifth of a second or an image for a fifth of a second. It'll be a little bit like that. It's almost statistical because there's so much evidence that and so little time that I'm going to have to rather fly through it. And but there is a hard copy available, and those of you that want to scrutinize the evidence and tear it apart, have at it. Feel free. If we can get through this together, uh, maybe we can establish that there are laws of cancer that will allow us to eliminate uh, virtually all fatal and metastatic cancer, which is what vitamin D excels at. Although in the proper hands and in amounts that are adjusted for various factors, it also greatly reduces the risk of cancer or incidence.
And that's the exact message that Grassroots Health was founded on with Carol and her experience with breast cancer and breast cancer treatment. And so this presentation, I mean, that makes this presentation that much more special and meaningful in honoring her legacy. So
Yes.
can you see the slides now? You can see your slide
Yeah,
now?
we see them perfectly
Okay,
well.
great. All right. So you just tell me when to move forward. I'm going to put myself on mute and
The
don't
slide.
leg.
I'd like to dedicate this to Carol and Dr. Leo Baggerly, who were both both scientists and both grand advocates and advanced the science as well as advocacy for vitamin D in an inimitable way that no one will ever match. So thanks to them. I want to thank my colleague, Dr. Edward Gorham, who worked with me on this presentation and on just about every presentation that I've given on the topic. And he continues to work today with me as two amigos interested in the use of sunlight and vitamin D in the prevention of fatal and metastatic cancer. And to my late brother, Dr. Frank Garland, who was the third amigo in our team. So again, welcome to each of you in every spot in the world, whether you're in Chinatown or Truth or Consequences, New Mexico, or anywhere in the world's capitals. I'm glad you're with me today. So let's go to the next slide. So I'm going to just briefly go through the goals of this study session to you, just so we know where we're headed. And the points that we're going to make and the evidence we will present will show that when there's higher solar UVB or vitamin D, the fatality rates of many internal cancers are low due to less spread. And then I'm going to propose three laws. Originally called them the Garland-Gorham laws, but it was a mouthful, so I'm calling them the GG laws. And the first is that when there's more vitamin D or UVB sunlight, there's going to be less metastatic and fatal cancers. And next slide, please. And the next slide will show you the other goals. There's a second law we're proposing, second GG law, and that is that we should aim for at least 50 nanograms per ml, generally not to exceed 100 until more research is done in that upper range. And the third law, and this one is often violated to terrible effect, and that is bolus dosing of vitamin D is ineffective against cancer. We know it from two major studies that use bolus dosing. One tried to use an annual bolus dose, another one used a semi-annual, and one used every 2 weeks. None of them worked. It has to be, vitamin D has to be administered every day if it's going to prevent cancer. And then we'll talk a little bit about the mechanism by which this is accomplished. Next slide, please. So we'll review at the end of the presentation some tools for preventing the horrible types of cancer that make cancer, has been dubbed the emperor of all diseases because it's so hard to treat. And that is daily intake of no less than 4,000 IU a day. We hope that will go up with time. And it should be higher than that in people with high BMI. And then finally, if we are going to stick with the recommended no adverse effect level of the National Academy of Sciences 2011 monograph and stay with 4,000 IU a day, then to get to those higher reaches of vitamin D in the blood, metabolites in the blood, we're going to need a little bit of either sunlight or pure ultraviolet B for about 10 minutes over 40% of non-facial skin area. No point in exposing the face that gets enough light anyway. And that amount has to be adjusted for the time of year, your skin type, and the body mass index. Otherwise, it's less likely to be effective. Next slide, please. So much for the goals. Let's see what we've got coming up. Oh yeah, it's a good idea to test the serum 25 quarterly or semi-annually until it's in the safe range of at least 50 nanograms per ml. And that's essential. It's not 30, it's not 40, it's 50 if you want to prevent cancer. And then every 2 or 3 years, ideally in the winter or early spring. Next slide, please. So it all started, this whole thing started with the sun back in 1940 when a scientist named Apperly noticed that there was more cancer at higher latitudes. And but nobody responded to it. He published it in a journal. It was not in Index Medicus. We didn't know about it. No one did. But he had hatched the idea that at high latitudes, sun or places where there's a lot of sun, there's less internal cancers. So we owe a great debt of gratitude to William Apperly. Next slide, please. So in order to check on Apperly's theory, which had just been tried out in a few cities, we redrew a map from the National Weather Service that shows the amount of sunlight reaching each point in the United States. And this was done by our group at Johns Hopkins. And you'll see that there's quite a bit of variation. The sunlight is way down in, say, Arizona and New Mexico, around 500 units. And these are calories per square centimeter. And up north, it gets down as low as 300. So almost a twofold range, not quite. But there are great differences in the amount of sunlight we get. Next slide, please. Well, as it turns out, there are also great differences in the amount of breast cancer. Today, I'm going to be focusing mostly on breast cancer because it is the lowest of the low-hanging fruits that's most, along with a couple of others, strongly associated with sunlight, the absence of it. And in the northeastern quadrant of the United States, there's very little UVB sunlight. There's two reasons for it. One is the latitude. Another is the circumpolar air mass that keeps the air cold and keeps people from exposing their skin to the sun. And then finally, and very potentially harmful, the precursors of acid rain, ammonium sulfate particles in the atmosphere, some sulfur dioxide gas produced by the combustion, particularly of soft coal in the Pennsylvania Valley, that infect the whole, and by analogy, infect the whole northeastern region of the United States, letting almost no ultraviolet B get through. And that's, we believe, produced this pattern. It's not as prominent in the West, where the air does not contain the sulfates and also does not contain much sulfur dioxide. It's illegal to release them in most of the West, and doesn't have the powerful influence of the circumpolar air mass, since the temperatures are buffered in the western half of the country by the power of the Pacific Ocean and its buffering effect on weather. And you'll notice that if you look for the places where are lowest, that particularly prominent is New Mexico, where except for Albuquerque, it's low, and it's even low in Albuquerque. It's low in Arizona, it's low in California and Nevada, and throughout the deep South, with the exception of Cancer Alley, which is around the vicinity of New Orleans, Baton Rouge, and the chemical plants there, which are producing breast cancer. Um, you see a little bit of pink in the eastern coast of Florida. We believe that's due to migrants. Many people retire from the Northeast to Florida to get the sun in the last years of their lives. And we think that's what's causing that little stripe of pink in the retirement areas of Florida. So this was discovered many moons ago, back in 1969, but nobody's done much about it. Next slide, please. So we decided to take the question out once and for all on the whole world and see what it looked like if you plotted the incidence rate of cancer according to some measure of sunlight. And once we started it, we thought, well, hey, there it is for breast cancer. But I'll show you what happens. So buckle up. Here we go. Next slide, please. So we decided that the best way to show this is to have the measure of sunlight on the horizontal axis with 0 at the equator, and then show the southern latitudes as negative values on the left side of the 0 point, and the latitude values, and this could also be UVB, they behave just the same, on the right side of the curve as positive numbers. And again, the equator is at 0. And so what we noticed is that first thing we noticed was New Zealand. If you look at the upper left corner, New Zealand is the most reliable indicator of a place with very poor ultraviolet exposure. And there's several reasons for it. One is that it has terrible weather. Anyone that's ever lived there will tell you that. But also it's because the Earth's orbit is not circular, but elliptical. And during the winter in the southern hemisphere, the sun is further away from us than it is during the winter in the northern hemisphere. So that winters are more extreme in New Zealand than they are in corresponding areas in the northern hemisphere. And New Zealand was what really stuck out. Also, Australia in the southern hemisphere. We think of it as being warm because we think of Ayers Rock and the outback, but it has harsh winters too. And so that's the first thing that stuck out. And then if we move to the upper right corner, we see a bunch of places like Hungary. It's typically Eastern Europe, Czechoslovakia, the Netherlands, Denmark, having very high rates as well. And those places also are at high latitudes, and they are areas where coal is burned, and famous for rickets because of the interference of the transmission of ultraviolet B by ammonium sulfate particles in the atmosphere, and sulfur dioxide gas. So then if we don't move down to the middle, we see most of the tropical countries like Guinea and Tanzania. And these are age adjusted. So this is for people of the same age being compared in each of these countries. And it tends to be quite low and at the equator. But there are always exceptions. Some people say the exception proves the rule, meaning it proves the rule is true. Others say it tests it. And an exception is Senegal. We would want to go to Senegal and find out what it is, but most likely it is parasitism, because when you're dealing with colon, this happens to be colon cancer in this slide, although the slide for breast cancer we'll see is similar. The parasitism does play a role. And if you have a lot of parasites living in the colon, it will cause cancer. Next slide, please. So let's look at female breast. We see upper left, New Zealand, and again, Australia. These are Argentina. These are southern hemisphere places with very powerful deficiencies of UVB in the winter due to sun-Earth distance and the weather there, which is also influenced by the sun-Earth distance. Then as we go down toward the center, the 0 point in latitude, we see places like Mozambique, Rwanda, Democratic Republic of the Congo, Papua New Guinea, Swaziland, places where the cancer is almost non-existent, and this is breast cancer. What little cancer does occur there in the breast is almost all due to infections. We call it mastitis, and not to vitamin D deficiency, but it can human beings live in the world in places where there's essentially no breast cancer and virtually no adenocarcinoma of the breast, which is the type that we have. And then as you move up to the right, you see Iceland, notable for its ice palaces, quite a cold place. It's hard to get your skin exposed to the sun during much of the year. The United Kingdom, famous for rickets and for cancer. As you know, both the king and the king's daughter-in-law have cancer. And when we look at the history of writings about cancer, they were centered in the United Kingdom because that's where the cancer was. Also, the Eastern European countries. And you see Norway is up there along with the UK. In the USA, our rates are higher for two reasons, I think. One is our latitude. We're not at the equator, but we also do a lot more hunting. Since 1960, we've been doing mammography. It doesn't do much to reduce incidence. It tends to make incidence run higher because we're looking for it. And we're finding lesions that may or not really have been cancer. And then, as we discovered, as we went through hospitals in the United States and looked at medical records, breast cancer in situ in the USA is called breast cancer because the remuneration from insurance is very good for breast cancer, but not for breast cancer in situ. So hospitals and medical practices typically code in situ breast cancer as invasive breast cancer, and that also builds up the rate. Israel copies our plans, and so they're up there rather high too, but also probably because of migration from Northern European countries during the 1940s. And so this is what it looks like. And let's go to the next slide, please. This is breast cancer. Note that it's a parabola. Next slide, please. And here we are with bladder. And bladder's an example of a kind of parabola. We didn't draw these lines. The computer draws them. It's a simple quadratic equation, just about like, when Einstein said E equals mc squared. This is just as much a law of nature as that. And you'll see it just reproduces itself again and again. People are distracted by the exceptions, but they need not be. In the case of bladder cancer, you'll notice it's high in New Zealand, but it's also very high in in Luxembourg, Germany, and the Netherlands, where the rickets was so prominent. But what's EGY doing up there? That's Egypt. And the reason that Egypt is there is because people in Egypt tend to live along the Nile, and the Nile is infested with schistosomes. These are worms that attach to your bladder. And over years of irritation of the bladder, they cause bladder cancer. So don't be surprised when you see it. In fact, it's also helpful when we plot these things to look at the outliers because it helps us to draw attention to places in the world where something could be done. If we could kill the schistosomes, Egypt would probably return to the law of cancer line, which is a parabola. And next slide, please. So we thought, well, what is it true for some other cancers? You're going to be looking at approximately 40 years of research on this. Again, you see New Zealand as a starter in the upper left. It's generally always there. And then moving down toward the equator at the 0 latitude point, you see places like Equatorial Guinea, Swaziland, Namibia, all kinds, almost every tropical country is down there, with some exceptions. And exceptions where they occur are, we think, rather odd. And when we contacted the governments of the countries that were in the upper right, way above the line, we found that what they had in common is that they love to eat lamb, and they have food that's made out of lamb brains, not well cooked. And we believe that viral inflammation of the brain as a consequence of eating neural tissue from lambs is creating this problem in Greece, Croatia, and Macedonia, and Lebanon, where lamb is a delicacy and is often eaten a la carpaccio. Very unwise practice, and we hope they'll address it. But looking more on the line toward people that have an intake that does not include lamb brains, we see places like Norway, and sorry, there's their numbers on the other places, but they're countries, typical Eastern European countries in the UK. And you see the USA is about a little bit above where it ought to be. It's probably because we're better at diagnosing it. Belize is a little high. There's a lot of parasitism in Belize. There's also such parasitism in most of the countries that are above the line, and including in Belize, a disease known as visceral leishmaniasis, a parasitism that causes cancer too. So, but the overall main effect, the strongest effect, is the effect of latitude. Next slide, please. And this looks at brain cancer in women. You see the same thing. The dietary habits are similar. So they tend to be way above the line for countries where eating lamb brains is popular, but more along the line, like for Iceland, which is cold, very little UVB, and where they don't eat lamb brains. And as you move down toward the equator, you see all those countries there. They're again the same countries. They're all the tropical countries, both in Africa and South America, for the most part, with occasional exceptions. And New Zealand standing out as it usually does. So it doesn't matter what sex you are, particularly. If you're at a low latitude, you're going to get a brain cancer rate of 1. And if you're a high latitude like Iceland, you're going to be 6 times higher. So people of Iceland, beware. Next slide, please. Now, we can also look at this for other cancers. Here's one. This is lung cancer. And at first, we didn't pay much attention to it. Like most people, we were overwrought with thinking about smoking as the cause. But smoking is falling into the background now. Only 11% of people in California smoke. And we're seeing more and more cases that are in non-smokers. So the reality is that just as strong as smoking, and now smoking is no longer the predominant influence, is sunlight. And this is the same kind of plot by latitude. And we see New Zealand up around maybe 35 or so. And on the left side, then we go down to the tropical countries, and you see Guinea and Namibia down really low. And this is age standardized, so it's not due to younger ages in those countries. And then really high in the upper right, which these tend to be at high latitudes, and where smoking got very popular after World War II. People were kind of trying to emulate the Lucky Strike generation. And that's playing a role in keeping certain countries like Hungary above the line. But overall, it conforms to the line drawn by the computer of a parabola. Uruguay is interesting. We are kind of worried about a drink called mate, which involves a burning of fibrous vegetable material in Uruguay in a way that's unique to Uruguay, followed to some degree in Argentina. And we think that that's probably rather carcinogenic. Next slide, please. And here we see the same thing. New Zealand, as usual, holding the upper left. And then down in the tropics, you see Uganda, all the different Swaziland, little countries, some of them large countries, but with rates of about 0 near the equator. And then it flying up to places like Canada and Denmark, where the rates of lung cancer are very high. Some contribution here of smoking. Otherwise, the points would be on the line. And if we can totally get rid of smoking, these points will all move closer to that line. Next slide, please. So this just, it gets monotonous. We keep doing the same thing with each cancer, and we keep asking the computer to draw the least squares line, and it draws a parabola, and it looks the same for almost every cancer. And, we could detail what the exceptions are, but those are due to parasitism in the most part. And those are easily conquered if we have the national will to conquer them. And then the more points will move closer to the line. Chronic irritation is a cause of cancer and has to be taken into account. But still, the parabola is there, and we see it, for so many different countries. Now, this happens to be leukemia, and it's even true for leukemia. And we see New Zealand way up high. Again, New Zealand farther from the sun, 7% less solar irradiance, less UVB, terrible weather, doesn't get much UVB. And at the upper right, we see the Eastern or Northern European countries, which also burn a lot of coal, which have acid rain. ammonium sulfate in the atmosphere, high latitudes, and relatively long winters. So it's true of leukemia as well. Next slide, please. So here we're looking at leukemia in women. And again, this is a kind of a gender free thing. It's common in both groups. And the high points that you see are typically New Zealand on the upper left with that terrible geophysical situation that they are in, and the European countries like Denmark and the usual suspects at the upper right. And it drops to about zero when we get down to Gambia, Senegal, Fiji, places like that, where there's a lot of sun. People are outdoors quite a lot. And again, this is not due to age differences. We also have corrected this for expenditures of health, ponderal index, alcohol consumption, tobacco consumption, and we get the same results. It doesn't, adjustment by multiple regression does not change this. It's a very persistent finding. Next slide. So what we're looking at now is multiple myeloma, a great mystery disease. And so the first thing to look for is the upper left. We see New Zealand with its terrible situation with respect to ultraviolet B, and Australia holding up the left edge. And that's actually a point up there around 5 per 100,000. And then we see it dropping down to zero at Vanuatu and Fiji and near zero at Swaziland. So there's at least a threefold, and at the extremes, a fivefold or more range of variation in the incidence. And these incidence rates are all reported to the International Agency for Research on Cancer, and we're quite confident in their accuracy. Next slide, please. And here we go again. Here we are with multiple myeloma, and this is in females, and the pattern is the same, except there's something females are doing in Zimbabwe that's pretty terrible for multiple myeloma. Might be related to some ritual practices that are done there. And we see New Zealand as usual in the upper left, places like Norway, Iceland, cold places where people have igloos, we're used to, and have hotels made of ice. Next slide, please. So what's all this due to? It's due to the sun. It's the source of the UVB. UVB converts the cholesterol in the skin, 7-DHC we call it, into vitamin D, not even a change in molecular weight, but then it becomes a wonder thing. Next slide, please. And what we're focusing on here is this little band of wavelengths. I don't know if you can see the cursor, but if you can see the cursor, I'm pointing to this little group here. And then this is the ultraviolet B portion. This is where the good is done by the synthesis of vitamin D in the skin. Most of the ultraviolet is ultraviolet A. 90% of it is ultraviolet A. This is where the damage, unfortunately, is done that the sun will do. And then this is visible light, a smaller part of the spectrum than the ultraviolet A, but larger than the ultraviolet B. And then as we move to the right, if we did, we would be into heat, which feels great on the skin, and may do some good in its own right. Next slide, please. So what happens when ultraviolet B hits the skin, and we're showing the spectrum like you would get with a prism? It converts cholesterol, 7-DHC, it's dehydrocholesterol, very common type of cholesterol, to provitamin D. You have to have some warmth. You need some infrared radiation for the conversion to previtamin D to occur. So you can't just use a cold source of ultraviolet. That's the benefit of the sun, is that it's warming the skin, and at the same time it's making the vitamin D, and the combination is what produces the vitamin D3. And that's stored in the skin, and the skin is a good reservoir for it. Ultimately, it goes into the plasma and is stored, it's converted to 25 vitamin D, which is believed to be a more active metabolite in many ways in the laboratory, and ultimately to a far less common but stronger metabolite, 125 dihydroxyvitamin D. We call it calcitriol, which is made in the kidney, and it can be made actually throughout the body as well. Next slide, please. I'm showing this slide just to show you how things go with science. It's a little bit of history. When we first started this work, we would get a finding of, it's a logarithmic scale. So if you look at the first study, it was Garland back in 1980s. It's about maybe 0.7, about a 30% reduction in the risk of colon cancer. in a cohort study in the Lancet that we did. But as time goes on, this happened with smoking and with a lot of other exposures. You continue to get the findings, but they've become significant. So the second study that Braun did, they also found it, but not quite statistically significant. But then as we got better at it, it tightened down. Next slide, please. So this is we're going through evolution of acceptance of vitamin D right now. First it's ridiculed, and it was for a long time after the rickets evolution passed and we conquered that disease with sunlight, UVB, and vitamin D. But then it's violently opposed, and there are many vitamin D haters, self-described vitamin D haters. Most of them, oddly enough, operate from the northeastern quadrant of the country where the average vitamin D level can be 15 to 20 nanograms per ml, and they say that's just fine. But then ultimately, as time goes on and studies are reproduced, it's regarded as being obvious. And I think we're almost to that point, but not quite. Next slide, please. So we got going on this by noting the very distinct geographic distribution of colon cancer, as I mentioned, it being about twice as high in the northern tier of the United States as in the southern. And everybody was blaming it on poor diagnosis in the South. That turned out to be not that this is the real thing. And I'll show you what the dose response looks like. I'm not going to go over every study, but just some of the initial ones that help to establish the validity of the hypothesis. Next slide, please. So this slide shows you a study done by Tangria, and where they looked at the amount of serum vitamin D that were needed to cut the odds ratios. And what they found was that you cut them by half if you get people just even up to 23 nanogram per ml, that there's a huge increase in risk, as you can see, if you have really low levels, those levels that we see as non-detectable when the vitamin D analysis results come back on blood. But you'll also notice that the points are quite close to the line. We rarely see this in biology. Usually this looks like a physical law rather than a biological observation. But that's what it's like. And there's every reason to believe that we're going to get rid of colon cancer if we get that intersection with the line here. It looks like in this population, we could do it with 25 nanograms. So it is easier to prevent colon cancer. It's a terrible disease, and all of it can be prevented with enough vitamin D in the blood. But this shows it. Next slide, please. And you always like to have a confirmation, and Veskinich et al. Did confirm it. In their population, it took a little more. It took 37 or so nanograms to cut the risk by half. And as you can see, it's pretty linear. It might flatten out, but I don't believe it will. I think you'll see an intersection somewhere near 45 or so nanograms per ml. So this confirmed that vitamin D can immediately prevent half of colon cancer. And that means less colonoscopies, less loss of the bowel, less premature mortality, and less misery. And yet nobody's doing anything about it. It's a crime. So now how does this relate to breast cancer, which is our topic today? Next slide, please. So I'd like you to think a little bit about breast cancer by 25-OHD. And it's very, very similar. This is a wonderful study done by Lowe and her colleagues in England. And she looked at odds ratios for breast cancer according to the serum 25-hydroxyvitamin D. And in a wonderful paper published now 20 years ago, they found the same dose response relationship approximately as we did for colon cancer. We had predicted this, and they cited us in their research, and that's how it came out. One of the dots you can barely see because it's right on the line. It's at 50 nanograms per ml, and that's where the odds ratio goes down to 1.5 rather than the 4.5 that it was earlier. And then as you just continue down, you see it eventually goes to 1 compared to an odds ratio of approximately 4.5 for people who are really low on their vitamin D. So they found 4.5 times as much breast cancer, and this shows it as a more graphic display directly showing what happens when you get up to 60 nanograms per ml. And the authors concluded that vitamin D prevents breast cancer 20 years ago, and that it reduces the odds ratio to 0.17, which means that gets rid of 83% of breast cancer. Yet we're still letting people get breast cancer. We're letting it metastasize. We're letting them die. And it's just because of intransigence. We have all the scientific data that anyone would ever request or ever need to immediately take public health action. Yet we're allowing thousands of women to die each year and to suffer through the misery of breast cancer when it's totally preventable disease. It's just too crazy. But that's the reality. So please, if you remember only one slide, there are only one or two that I'd like you to remember forever if you can, but this one in particular, if you're interested in breast cancer, because it's a preventable disease, just like measles if we vaccinate, polio if we vaccinate, tuberculosis if we do case monitoring. It's totally preventable, and we have to just accept this. 20 years is long enough to wait and not act on solid epidemiological data. Next slide, please. So now, because of a study done at Harvard that found that vitamin D by mouth reduces metastasis, this has become the focus. Next slide, please. And, we wouldn't call cancer the emperor of all diseases. It wouldn't be the catastrophe that it is, the scourge that it is, if it didn't kill you. And the killing, 90% of death from cancer is due to remote sites, metastasis, spread of the cancer to the remote tissue. This study was done by Harvard. We advised on it. And they didn't find a difference in incidence over the period 5 years that they observed it. And they had a lot of non-compliance. But let's go to the next slide, please. What they did find was a significant reduction in the bad ones, the advanced cancers, metastatic breast cancer, lung cancer, colon cancer, bladder cancer, and others that people who were randomized to vitamin D had less of than those who were assigned to the placebo. The hazard ratio was 0.83. The P is 0.04, so it's statistically significant. And it is a 17% reduction in metastasis or death. And there are even few chemotherapy agents that will produce that. I've attended many presentations by pharmaceutical companies where you need to have a magnifying glass to see the 2% difference produced by the chemotherapy. And here we have a 17% reduction with just assignment to vitamin D, but with not very close monitoring of compliance. And as time goes on, I expect this will continue. It takes time for vitamin D to produce its effects, but it's already happening. Next slide, please. Now, some people could poo-poo it and saying, well, what is 17%? Well, it was stronger if you stratified by BMI. If you were lighter, you got a more potent effect. And to me, having worked in a cancer center for some 3 decades, I was happy that there were 48 people who were going to die of metastatic or fatal cancer that were prevented from dying in this 5-year period by taking 2,000 IU a day of vitamin D. And but that's not enough vitamin D to do the job. We know that. Next slide, please. Metastasis is now something that's really logical for us to attack. We have a model of it. It's called the DPE PRC model, for want of a better initialism. But what happens just quickly is that malignant cell detaches from the cancer mass, and vitamin D makes things stick together. That was discovered by Boveri in 1905. And so if you're low in vitamin D, your malignant cells don't stick together and they detach. They penetrate the duct wall of the lymphatics. That wall is tightened by vitamin D. It prevents penetration of it. Eludes immune attack. Vitamin D increases your immune competence. Normally, in the lymphatics, B and T lymphocytes would attack your cancer cells, but in low vitamin D status, they don't. And so let's go to the next slide, please. This illustrates it. If your cells aren't sticking well together, they detach readily from the primary tumor. If they're not high in vitamin D, it will penetrate into the blood vessel, the lymphatic, and then it will elude immune surveillance because the immune system is weak in people who are deficient in vitamin D. And then, since the lymphatic wall is weak, there will be extravasation, or the cancer cells will penetrate the lymphatic vessel, and then they'll colonize the lung or the liver or the brain, and that's when we're in big trouble. Next slide, please. So to continue the last steps, and the cell has to penetrate the wall of the lymph duct. Vitamin D tightens that barrier, keeping it from doing it. And then finally, and this is very important, vitamin D blocks VEGF, which is something that causes blood supply to go to tumors. If you have enough vitamin D, the tumors can't recruit a blood supply. If they don't recruit a blood supply, they don't spread, they don't invade, and they don't kill you. And then finally, the last step is colonization of the remote organ, which is what causes 90% of cancer death. The reason I've broken this into phases, as has some others, is that it shows that there are many points in the failure of the body to fight cancer that we could intervene on, and vitamin D is influential in all of them. Next slide, please. So here's what happens. It starts out in the milk duct. The tumor grows in the breast. It goes to the lymph nodes because vitamin D hasn't made it sticky enough to each cell to one another to inhibit what we call contact inhibition, which is the main thing that prevents cancer as a result of vitamin D. And unfortunately, it goes to the lung, the liver, the bone, and other places, even the brain. Sadly, all eminently preventable. Next slide, please. So the most telling graph of all came from Grassroots Health. Next slide, please. And maybe we tried to tell too much with this slide. Some of the participants here were co-authors of it. But what I'd like you to focus on, and this is a full disclosure slide, it shows all the cases in red, it shows all the people in blue, but the important thing is that little black line. And if you look at it, and we have to use the right edge of the scale, which is where the incidence rate of cancer is, and this is for breast cancer, you'll see that it's 2,000 per 100,000 population in people who are down between 10 and 20 nanograms per ml of 25 hydroxyvitamin D. And most of that is from the sun. Somewhere between 80 and 90% of the vitamin D in circulation comes from ultraviolet B exposure to the sun. So these are people that don't get any sun. They might be watching TV, they might be playing games, who knows what, but they're not going outside, or they're not exposing their skin. They're ending up with breast cancer. But you'll notice that the curve goes down, down, down. And by the time you get up to 65 or so, 63 nanograms per ml of vitamin D, you don't get any more breast cancer. It's dropped to, even at 65, it's down to 250 cases versus approximately 430 cases. So it's down, I'm sorry, as compared to 2000 or so. So it's down eightfold. So if you have low vitamin D, you're 8 times more likely to end up with breast cancer. Yet even the American Cancer Society doesn't bother to recommend that people increase their vitamin D, preferring instead to focus on early detection and surgical intervention, which are fine if you have the disease, but it's a preventable disease. It's like trying to treat polio and neglecting the polio vaccine. So if there's one graph of all graphs that have ever been published with respect to breast cancer, this is the most important one, and it tells us that the disease can be totally eliminated by maintaining more than 65 or so nanograms per ml of 25 vitamin D, the principal marker of ultraviolet B. So really, we could even stop at this point, but maybe we should, because we'll leave a few minutes for questions. If you're wondering if vitamin D is safe, it's quite safe. We studied lifeguards. They average 45. Many of them are 55 or 60, healthiest people in San Diego. And this was a presentation that we gave on it. And you'll see Jen Eliano as one of the co-authors. And we can just step quickly through the remaining slides if you don't mind. This shows you can't use a bolus dose. Poor Richard Scragg used the bolus dose. He got nothing. It was every 2 weeks he gave the vitamin D, whereas the others gave it daily, and they got the benefit. So if you ever think of using more than daily exposure to vitamin D or sunlight, forget about it. And maybe sunlight, but certainly not oral vitamin D. Bolus doses are no good. Next slide, please. And so, of course, we have to avoid processed meats, alcohol, tobacco. Next slide. We know this. Chemicals, X-rays, solar UVA, excessive amounts can cause some skin cancers. We have to be careful. And these all should be considered laws now. They're no longer theories. Next slide, please. So here we go. I better get going. We're almost at the wall. Let's consider ourselves at the wall. Stop right now. I won't review it for you because I want to leave room for questions, but I'm open to any questions that anyone may have.
Thank you so much, Dr. Garland.
Sure.
We did get some questions, and I apologize for fast forwarding through one of the slides. I saw some questions come in, and apparently I can't monitor the slides and the questions at the same
No worries.
time.
Great job of multitasking.
So I'm just going to go through the ones that were submitted first. And here's a question about vitamin D supplementation. My vitamin D level was 130 last time a few months ago, and my doctor was upset. I want to know if that is bad. I was taking 10,000 IU a day.
Well, I always believe we ought to err on the side of caution. And although I'm, you know, probably the most arguably vociferous advocate of high vitamin D, that's a little too high even for me. I would say that get it down below 100 until we know more about it. Someday, 130 may be considered appropriate if we really want to get rid of cancer, but we don't have enough information on any adverse effects that might occur at those high levels. So I think you're taking too much vitamin D. I would scale it back, stay below 100. Then you don't have to worry. And also, if you do that, you're going to flux a little more calcium through your kidneys. You're going to raise your risk of kidney stones by about 17%. But you can prevent it if you drink enough water, particularly in the hot season where we get dehydrated.
Mhm.
And if you really want to prevent kidney stones, 60% of which are due to oxalate compounds, avoid certain foods. And that would be don't eat massive amounts of spinach, strawberries, tea that's brewed for more than 6 minutes, and various other things that'll trick you in your diet. Any nutritional agency will provide you with a list of oxalate in foods. And if you're trying to avoid kidney stones, be aware of you can't be Popeye and eat spinach night and day and not end up with a calcium oxalate kidney stone. So yeah, I would scale back. I would stick with the 4,000 IU a day, approved by the National Academy of Sciences, but be alert to it going up to 6,000 because I think that would be a wiser choice as
Mhm.
forward in understanding adverse effects.
Right, right. And that also brings up the importance of measuring to make sure you're on a proper dose because
Oh,
you never know.
yes.
I would love to say 10,000 IU is great for everyone, but we do see in our study, we've seen that some people need, I talk about our husband and wife very frequently, where the wife only needed 2,000 IU and the husband needed 10,000 IU to be in that same 40 to 60 range. So it's really important to dose to target, right? You want to have a target serum level, not necessarily a target intake.
Oh,
But
absolutely.
that's
The serum level is everything. And we
mhm,
all should be testing. Ideally, we should test in February. That's the low point. Yeah, it seems like we don't care. We test anytime, but it's better to test when in doubt, whether it's February or not. But if you were going to set up a scheme, I would measure if I'm low, say I'm down around 20 or 30, I'd measure, quarterly at least, maybe semi-annually. And then if you're high, then maybe you can get away with measuring it every year. And then if you're really high over a long period of time, maybe every 2 to 3 years. But you should never let longer than that pass because life's changed. We move indoors, we start playing video games, we do things differently. And if we don't monitor it, then we're going to end up with a whole lot of bad diseases. And we just talked about cancer today. I could give you almost the identical presentation for type 1 diabetes of childhood, for type 2 diabetes of adulthood, for multiple sclerosis. The list goes on and on. We just happen to focus today on cancer.
mhm, yeah. I have a question here from Dr. Grant. Does 25 OHD concentration have a U-shaped distribution globally? I.e., is 25 OHD much higher in the tropics than at high latitude? And what about the effect of skin pigmentation?
Well, that's an outstanding question from a distinguished scientist whom I'm pleased to consider a colleague. And it's a very good question. Unfortunately, we don't have much data from uh, other latitudes. When you get near the equator, people don't think about vitamin D. It's just not on their bingo card. So we don't, for the most part, we don't know what their vitamin D levels are. I think it would be great to do a study, though, in which we scrutinize the literature for every single study that's ever been done that's measured vitamin D and in the blood, 25-OHD in particular, even better, 25-OHD3, if we could get that. And if worldwide, we'd probably want to focus on the 25-OHD3, which is specific for vitamin D3, which is the only form of vitamin D that prevents cancer. And vitamin D2 is popular in some places because there's a profit motive in it. So we would want to do that. And we need it. And also, we have this problem of people just measuring vitamin D casually, usually in nurses, lab workers, medical students, people that are available, rather than going out into the barrios or the neighborhoods or the whatever places where people live and measuring that. So it's an urgent need to do it, and I hope somebody will take on that job of figuring the answer to that question and determining just what the shape of that curve is. But it is a great and pregnant question. Thank you, Dr. Grant.
Yeah. And I do have a question to follow up in a way, because Sunshine Month, we really like to educate about the additional benefits that we receive from natural sunlight. And I know we're talking specifically about UVB, but we know that UVB can also help our body create nitric oxide, beta endorphins, and other beneficial molecules, hormones, neurotransmitters that maybe could those also in a way play a part in the cancer prevention? And do you think if we were able to measure the vitamin D results, would we really be able to say eventually, okay, it is the vitamin D production from UVB? Or how could we possibly consider those other components of UVB?
Well, as a stopgap measure, I would say that we ought to be considering UVB as a vitamin, as a micronutrient, in a sense that everybody needs to get a little bit of each day. We don't want to go crazy with it, but because there are probably other photo products and we know there are other photo products other than vitamin D that are made when the sun hits the skin. They're vitamin D compounds that are close to it. And of course, oxides of nitrogen, there's a whole bunch of beneficial things that happen when UVB hits the skin. So until we sort it out, we probably ought to be getting everybody to get some sunlight or solar UVB, if possible. And if not, maybe artificial UVB that's got no UVA in it, which would make it maybe even safer than sunlight. But yes, but not a lot. 10 minutes a day is a good average for most people. If their skin is dark, they might need 20. If it's light, they might need 5. And it should be adjusted for ponderal index, because if they're heavy, they need a little more UVB than if they're not. And it's kind of crazy to try to predict what somebody's vitamin D level will be unless you know quite a bit about them, including their weight and their precise skin type and related factors. So I'm sorry if I'm diverging a little bit from the question, but
No, in fact, there's another question that somebody wrote in asking for your recommendations for natural sunlight exposure. So this is,
well, I think it's pretty clear that it ought to be on the average 10 minutes a day of springtime sunlight, which would be sunlight at the equinoxes. You can find that for your area of the country, but it's not easy to find. But NASA has some data on it. What we need is a UVB photometry network that has photometers that tell us the amount of UVB at each site. There are very few of those, and most of them are overloaded with UVA. We have something called a Robertson-Berger meter at a few sites. It's not a UVB meter, although it includes UVB. But we really need a spectrophotometry network in order to calculate the amount of UVB that reaches the ground. But we do model it. We know the thickness of the ozone. We know the solar constant. We're able to model it, and we have in studies that we've done and published. But it would be far better to have a worldwide spectrophotometry network where we could measure the amount of ultraviolet B reaching the ground and then specify even more precisely. But for most people, it's going to be 10 minutes. If they're quite a bit overweight, it's probably going to be longer. And they've got to be careful about it. And that probably never should exceed about 20 minutes. And probably rarely would exceed, be less than a couple of minutes a day. But it's critical that it be in the middle of the day. It should be within an hour of solar noon. In California now, we're on daylight time. So solar noon is at 1 o'clock. And you better check your country as to whether they're tricking with the clock so that you can get within an hour of solar noon. Equally important is the amount of skin area. The amount of vitamin D that's synthesized depends on the number of square centimeters or inches of skin. And if you're wearing your clothes, you're not making vitamin D. Most vitamin D is probably made on the shoulders, which are like black body radiators, except in reverse. They wonderfully absorb ultraviolet B from the whole sky. So you've got to have your shoulders exposed if you're hoping to make any vitamin D. And you actually need to have, if you're going to be out for 10 minutes, you need 40% of skin area exposed. And the
Hmm.
more skin, the better, except maybe very sensitive sites like your face and your genitals, where you would just as well not expose them needlessly. But otherwise, the whole body should be fair game for vitamin D biosynthesis, and it is good to vary it. It's not wise. Say you're going to use an artificial source of UVB to only do it in one place. Keep it going, keep it moving. More like simulating life, and simulating life at the time when the sun is high in the sky, which is
Hmm.
normally light on the shoulders.
Right, right. And of course, always avoiding sunburn. That's the key to skin cancers. And I know Dr. Gorham, he's presented one of my favorite topics, the skin cancer sunscreen dilemma, where he actually shows that as the use of sunscreen increase, the incidence of melanoma increase as well. And there's been question for whatever reason, probably due to study design, about whether or not the use of sunscreen blocks vitamin D production. And there was a great paper that just came out last year, a randomized controlled trial that really definitively said, yes, if you use sunscreen, a higher UV index, or I'm sorry, SPF 50 regularly, yes, it does block the vitamin D production. And so there's those other components. It's kind of tricky sometimes to balance the exposure and that avoidance of the sunburn, but absolutely essential. If you wouldn't mind adding to that.
Well, we call it sunburn, but it's actually what I call a photoprotective response. It's a uh, distribution of blood to the surface of the skin in order to supply the melanocytes with enough blood in order to synthesize melanin. And it's a normal reaction to the sun. It keeps us from going out and getting too much sun because it hurts to get sun on a sunburn. So people are, they're worried about sunburn, but sunburn isn't really the key issue as much as the amount of exposure of the basal layers of the skin that contain melanocytes and keratinocytes that are sensitive tissues. Almost all the light that gets into the bottom of the skin in the ultraviolet region is UVA. It's 90% UVA at least. In later parts of the day, it's 100% UVA in the UV spectrum. So it doesn't do any good to get out at 8 in the morning or 3 in the afternoon. You may as well not be out in the sun at all. But uh, avoidance of sunscreen, avoidance of sunburn is a good idea. You have a feeling you're overdosing when you do it, but it wouldn't. It's not the key issue. The actual key issue is preventing the photons that penetrate to the base of the epidermis from doing that, and that's done by what the kids call the horny layer, the stratum corneum of the skin, and the other layers that intervene between the atmosphere and the base of the skin. And that's normal. The skin hypertrophies in response to sunlight, and it gets tan and it gets thicker, and those are all normal protective responses, and we shouldn't interfere with them. We noticed that when sunscreens were introduced back in the mid-century of the past century, melanoma incidence rate shot through the roof. It looks like a rocket ship, just like diseases that we deal with today, like autism. It just went crazy, and it's still crazy. And it maybe was because it enabled a culture of too much sunlight, with the idea that if you prevented the sunburn, you were going to prevent the cancer, which isn't true. And so now we have a lot of melanoma, and I'm pretty sure a lot of it is due to overexposure to the sun. We have to be careful about, particularly for lightly pigmented exposure to the sun. As a pigment increases, inherent pigment in the skin, we don't have to go as wild about being protective of the skin. But we have to be careful, and it's nice not to have the skin turn red, and I'm say that's fine, but I don't hate it either, in the sense that it does represent a natural response to the sun. But if you keep doing it every day, you're asking for trouble. So
Mhm.
it's really got to be modest exposure. Ideally, you should be monitoring your vitamin D level in the blood to make sure you're not getting like the person who called in that had 130 nanograms. Yeah, it should be checked. And if you use a sunscreen, it should be a neutral clay. Well, some sunscreens are made of multiple azo dyes that absorb different spots in the UVA spectrum, but still transmit a lot of it. And what happens when a sunscreen absorbs a non clay sunscreen absorbs ultraviolet A energy? It just moves it to a different part of the spectrum. It doesn't get rid of it. It translates it. And so there's still UVA getting to the skin, even if you have these rather narrow gauge filters that are put into the fancy sunscreen. So if you must use a sunscreen, clothing is better. But if you really just want to expose that skin after the 10 minutes of vitamin D photosynthesis, then be sure it's titanium dioxide, zinc oxide, tested for sensitivity in some little area of your skin first to make sure you're not sensitive to it, and use only a clay-based sunscreen.
Thank you for that. I
Sure.
know a lot of people are looking for those practical tips.
Well, that's one for sure. Hey, in your pocket for the first 10 minutes or so, and maybe the first 2 minutes if you're really fair, and the first 20 if your skin is dark.
Yeah, but nothing beats that hat and a little layer of clothing if possible.
Oh, that's possible. Yes. The clothing has an SPF. Most of it has an SPF of 5. We'd like to see some clothing that transmits even more UVB and less UVA. And I hope someone will invent that, a kind of
Oh,
a
I've seen them popping up on social media here and there. I'm gonna have to look
let's
into them a little bit more, though.
yeah, right for them. Let's make vitamin D with our clothes on. Then people wouldn't be as maybe unwilling to expose their skin because they wouldn't be showing off, but they would still be making vitamin D. That would be really good cloth.
Yeah. Well, we had a couple other questions, but I know we're over time. And I believe one of the questions you've answered, but I do want to say she mentioned these smiley curves are absolutely fascinating, she said. But we did cover the other factors that could explain the
Okay.
results. So I think with that, I think we're done with our questions. And unless you have anything else that you want to close with.
Well, I just thank for the patience of everyone. As I said, you had to buckle up because we covered 40 years of research in a matter of minutes. And if you didn't leave, it's amazing to me. But I'm very glad you stayed with us around the world, wherever you happen to be. And thank you for your paying attention to it and maybe doing something based on it.